Hello everyone, and welcome to this ninth video that will be part of this series about the Go programming language. Today we're going to look at two types of important operators as promised in the last video, and these are comparison operators that, like the name suggests, they're operators used to compare values, so values stored inside variables, but also values in general. And then we will cover also logical operators, that are operators that act on boolean values. So let's first start with comparison operators. So think about, for example, also mathematics. What kind of comparisons would you do between numbers? So let's start with numbers. Well, for example, you might want to know if two numbers are equal, or if two numbers are not equal. Or on the other hand, for example, you might want to see if your number is greater or number is smaller. So how can you do that? You can do this in Golang via the following operators. So we have 6 important comparison operators in Golang. The first one is the equal to operator, and this is quite important because at the beginning you might get it wrong, but the comparison operator for two numbers being equal is the double equal sign. So this is the operator for equal to. And well, why? So sometimes some people just might write only just one equal, but notice that this in Golang is an assignment operator. It is not an operator for comparison. So keep this in mind. Then the second operator is the not equal to, and is represented with an exclamation mark and then a equal sign. And so this is basically not equal to. Sometimes not equal to is also called an equal to. Then the third operator that we need to keep in mind is the less than operator, and this is just your regular less than operator. Then this is the greater than operator, and then you have the greater than and less than or equal to operators, which are still very important. So the less than or equal to operator is written like this, and so let's write it less than or equal to, whereas the greater or equal to is written like this, greater or equal. So with this said, we now have the 6 comparison operators that we will treat in this video. Now let's make some examples with them. So also notice that when we compare two numbers, meaning that we have, for example, a number A and a number B, and we compare them with one of these comparison operators, then the result is a boolean value, because of course when we compare two numbers, we basically say, okay, is this number greater than or equal to this number? So it can be either true or false. Or is this number equal to this number? Then it can either be true or false, of course. And so this is the reason why the result of this comparison is a boolean value. So let's start and declare maybe a variable a, let's say equal to 23, and then another variable b equal to 25. Okay, so now let's from println a equals b. So let's print out to the console if a is equal to b. Let's see what happens. Well, as you can see, it gives false. Why? Because b is different than a. But what if we change 23? Then let's see what happens. We get true, because of course 23 is equal to 23, namely is equal to itself. So now let's try to print out, on the other hand, if a is greater than b. And as you can see, this gives false. But if we include the equal sign, meaning that if we check if this is greater than or equal to, then we will get true because they're actually equal. Now let's increment a. So let's set it equal to 28. Let's see what happens if we run it. As you can see, we get true because of course it's greater than b. So now let's also check. Let's also use the different operator. So let's see if an equal to operator, and as you can see, this also returns true because they're not equal. So this is a very quick introduction to the comparison operators. So you actually also can compare string. So if you have a string, for example, that is var a string is equal to hello, and then you have another string b equal to hey, then let's see what happens. You get true. In fact, you can say, well, is this string equal to this other string? But let's try to now change this to a low, so let's change the value to exactly the same one. Let's see what happens. We get false because they're actually equal. Not only can you compare strings like this, so meaning you can check if they're equal, you can also check if a string is greater than another string. And this might be a little confusing maybe to some of you if you haven't, if you're not super familiar with character encodings such as UTF-8 and ASCII and so on. But the reason why some values are bigger than others, or some characters are bigger than others, is because of their position on, so basically their numeric value to which they're mapped. So let's try, for example, and compare A and capital A. So if you run this, you get true. In other words, you get that small a is bigger than capital A because it comes after capital A in the encoding. And so you can try, but let's try to put B here instead of A. Let's see what happens. We get false because B comes after A. And so this is also how you can compare strings with equal to, not equal to, and less than or equal to, greater than or equal to, and so on. So with this said, we can now move to logical operators that are the following. So the first one is the logical AND, and that is represented by the following symbol. Then we have the logical OR, and that is represented by this symbol here. And then we have the logical NOT, that is represented by this exclamation. And so we might ask, well, how do these operators actually act on Boolean values, and what kind of output do they give us? So if you're familiar with logic, or if you have programmed in another programming language, then you can just straight out skip this part because it's exactly how they work, for example, in C or in, I don't know, Java or in JavaScript. And so you don't need to review them. On the other hand, if you've never programmed before, but maybe you have some background in mathematical logic, especially the beginning, not even mathematical logic, just the introduction that is given to these operators in discrete mathematics, then again, you probably already are familiar with them, and you just need to see how they're applied in programming. These operators are also part of a class of operators that are called true functional connectives. This means that basically, given some input that are Boolean values, then the output only depends on the Boolean values that you give in. So so for this reason, we can build some truth tables for these operators, and truth tables basically just give us a graphical view of what outputs these operators give us for what inputs. So let's start by building a truth table for the operator NOT. So the operator NOT, let's here put maybe true. Let's put false. Actually, let's put this is the input, and then this is the output. So if we compute NOT of true, then we will get false. And if we compute NOT of false, then we get true. In other words, the NOT operator just switches the truth value of the input, meaning that if we say NOT of something that is true, then we get out false. And then if we compute NOT of something that is false, we get true. So we can make an example. For example, let's print ln maybe NOT, and then let's insert here a true statement. For example, let's declare a variable x int equal to 5. Then if we say x is greater than 3, and that is true, but if we negate it, then we run it, we get false because we have negated a true statement. Now let's try and switch this with a less than sign. Let's see what we get. We should get true because we have negated a false statement. So this is how the not operator works. On the other hand, the OR operator requires two values. So the OR operator basically takes in two Boolean values and gives back another Boolean value. So, and the way in which it does it, it follows basically the following truth value. So I'm going to denote x for the first input, then y for the second input. Actually, let's use a tab to make it more clean. And then I'm going to denote x and x or y for the output. So let's first cover the case where both x and y are true. Well, then x or y is true. This might sound a little counterintuitive, maybe if it's the first time being exposed to these operators, because, well, in ordinary life, when you say this or that, you actually mean an exclusive this or that. You would not accept having both of them. For example, imagine go to the supermarket and buy, for example, apples or oranges. Imagine if the person you said this to would come back with both of them, then you would probably be disappointed. That's because that's another type of operator that's called XOR, or exclusive OR. But the standard OR that we will use, and also in Golang, yields true for x and y equal to true. So now let's suppose that x is true and y is false. Well, then the result of the x or y operator is true. Well, what about x false and y true? Then the result is true again. But the only case in which x or y is false if they're both false. So if they're both false, then the result is false. So now we can try and work a little bit with this operator. So suppose we again have the variable up there x that is equal to 5. So let's now try and print out the boolean value given by, for example, the expression x equals 5. And remember that in Golang the OR operator is with this symbol here. So x equals to 5 or x equals to 3. So one of them is false because x is not equal to 3, but the other one is true. So let's see what the result is, and that is true. Because again, according to the truth table we gave above, the first boolean value we passed was true. And so we are in this case here, so where x is true and y is false, and the result is of course true. But now let's try to pass in two false values. So x not equal to 5 and x equals to 3. And as you can see, we get false. So now we can make another example. For example, I don't know, 5 is greater than 0, or 2 is greater than 0. These are both true, and we should get true. As you can see, it's true. So with this said, I think we've said enough about the OR operator, and now we're ready to introduce the last operator of this video, that is the AND operator, also denoted with the symbol here. So let's write a truth value for it. So again, the first input will be denoted with an x, the second input with a y, and the output with a x and y. So the AND operator, on the other hand, returns true if and only if both of them are true. So if x is true and y is true, then the AND operator is true. Let's space it a little bit. But if one of them is false, so if either x is true and y is false, this is false. If x is false and y is true, then this is also false. And also if they're both false, then also the AND operator is also false. So this is just true if both of them are satisfied, and this is why it is often used as a way to check if two conditions are valid at the same time. For example, let's imagine that we want to print out if a number, our x, for example, is greater than 1 and less than 10. So this is an example of a situation where we want to use the AND operator, and we will see that the result is true because our variable satisfies both of these conditions at the same time, because it is equal to 5 and 5 is greater than 1, but it's also less than 10. But now let's see what happens if we say is less than 4 on the other hand, and we will see that this is false because 5 is not less than 4, and so x does not satisfy both of these conditions at once. It only satisfies the first one, but according to the truth value that we gave, this is not sufficient in order to make the AND statement equal to true. And so with this said, we now know how to work with comparison operators and logical operators, and now we're ready to introduce if-else statements in the next video. And because also we will see how we will use these operators extensively when we will work with if-else statements.